So why do we even bother using a radical symbol? Because the exact value of an irrational number can't be written any other way. Its decimals go on forever without pattern, like my teenage daughter telling a story. We use the radical symbol to represent an exact value without pretending we know all the messy decimal details. In this way, we give this slippery, mysterious, never-ending number a name. We can't capture it, but we can represent it. Radicals are revolutionary. And, of course, irrational. Multiplying and dividing radicals is surprisingly easy. If they have the same index, they're happy to combine. These rules come straight from properties of exponents. Just don't try this with different indices. Trying to multiply a square root with a cube root is like mixing oil and water. They're both liquids, but radically different. You can only add or subtract radicals if they're like radicals, meaning they have the same index and the same radicand. It's kind of like combining terms in algebra. You wouldn't add 2x and 5y, and you can't add 2 square root of 3 and 5 square root of 2 either. They're speaking different dialects of math. You've got to simplify each radical first. Sometimes they reveal a common identity, and then you can combine them. But if they don't match, no combining, no compromise. It's like trying to form a boy band out of a barbershop quartet and a death metal group. Technically music, but absolutely not happening. So why do we rationalize the denominator? Partly tradition, sure. But also because radicals in the denominator are messy and harder to work with in later steps. It's like saying, hey, we cannot keep our iffy guests in the basement. When the denominator is a single radical, we just multiply by the same radical to cancel it out. But when it's a binomial, like 2 plus root 3, we use the conjugate. The conjugate looks similar, but with a sign change. It's kind of like math's version of a breakup text. I'm not mad, I'm just flipping the sign and moving on. It clears out the radicals through the difference of squares. Efficient and emotionally cold, just how algebra likes it. Rational exponents combine two ideas, roots and powers, into one neat expression. For example, a to 3 over 4 means take the fourth root of a, then raise it to the third power. The denominator tells you the root. The numerator tells you the power. One way to remember it is this. The foundation is the root. So the denominator determines the root's index. Rational exponents may look scary, but they're just radicals in disguise. Same math. Different outfit. Let me leave you with one last thought. To simplify a radical is noble. But to oversimplify one, that is when a student writes root 2 plus root 3 is equal root 5, is how you summon Reductio Malformus. It looks like a correct answer. But it brings no credit, only despair.